exponential growth and decay. Our essential question is, what kinds of situations can be modeled with exponential growth or exponential decay functions? By the end of this video, you will be able to use exponential functions to model situations and make predictions. Exponential growth, f of x equals a times 1 plus r to the power of x. The plus indicates exponential growth. Positive means it's growing at positively at an exponential rate. A is our initial amount. R is the rate at which the function grows, and x is still the variable for the exponent. R is typically a percentage in these problems, so let's use decimal form. For example, for 29%, you'll use 0.29. For 8%, you'll use 0.08. Exponential decay, the only difference in this situation is we are subtracting 1 minus the rate. The a is still that initial amount, the r is still the rate at which the function decays, and the variable is still x. Again, r is typically a percentage, use decimal form. For 52%, use 0.52. For 3.1%, use 0.031. Write a function to represent an initial value of 550 that grows at a rate of 6%. So if our initial value is 550, it's growing at a rate of 6%, so we're going to use 0.06 for our rate, our r, and plug it in. We get f of x equals 550 times 1 plus 0.06 to the x, or 1.06 to the x. Find the value of the function when x equals 9. Well, we use this function. We just need to plug in a 9 for x, and we can bring that to our calculator. And we can type it in, 550 parentheses 1.06. And if you're wondering how to raise it to that, the a to the b function. That's where we can get our 9. So 929.21. So it's about 929.21. When you see these little squiggly marks, that just means it's about, and we're rounding. All right, write a function to represent an initial value of 2400 that decays at a rate of 13%. So decay, telling us we're going to use minus here. So the initial amount is going to be 2400. Our rate is 13%, or 0.13. We plug it into our function. 1 minus 0.13 would leave us with 0.87. Now, find the value of the function when x equals 10. Again, we can use our calculator to get so. 2400 times 0.87 to the 10th power. We could type that in here. 2400 times 0.87 to the 10th power. 0.87 to the 10th power. 596.2 says that's a 6. I'd round that to 22. 596.22. The population of Hillville is 5,000 people and grows at an annual rate of 15%. Write an exponential growth function that models the expected population growth. Well, our initial amount is 5,000. Our rate's 15%. We're going to use 0.15. So we plug it into our function, and we get f of x equals 5,000 times 1.15 to the x. What will the estimated population of Hillville be in 5 years? Well, we just need to plug in a 5 into our function. Can use our calculator. I'll let you be able to type this in and confirm that you can get 10,056.79. So we're going to say about 10,057 people. A video is considered a fan favorite if it receives at least 1,000 views per day. Amelia posts a video and her views decrease 25% each day. Write an equation to model the situation. Well, this is decay because it's decreasing. Our initial views were 8,192. Our rate is 0.25. So we plug it into our decay function, 1 minus 0.25 to the x. We get 8,192 times 0.75 to the x. It says graph the equation on your calculator to find in how many days total will her video stop being a fan favorite. Well, if we click into here and we type in the function, we type in 8192 times 0.75, and that was to the x. And we zoom out and we find our function here. Now this is when we're interested is, okay, 1,000. When is it below 1,000? So after day 7, we're still above 1,000. We get to sometime during day 7, or we could call it day 8, there's 820 views. So it will be where videos stop being a fan favorite. It'll be a stop being a video being a fan favorite on day 8. Less than 1,000 views in 8 days. Compound interest. Here's a new formula for you. A equals capital P times 1 plus R over N to the N times T, where P is the principal amount, N is the number of compounds per year, annually 1, quarterly 4, monthly 12, etc. R is our rate. We'll use in decimal form. T stands for our time in years, and we can just plug in the functions that we get when we get our problem. So Kimberly's family invested $3,000 in a certificate of deposit, a CD, for her when she was born. The interest is compounded quarterly, and the annual interest is 8%. What is the value of the CD at the end of 5 years? We've got our formula here. P is the initial amount invested, the $3,000. R is our rate, 8%, we'll use 0.08. N equals 4. We got that because it says compounded quarterly. Quarterly implies 4. So we plug all those numbers in. P, 3,000. R, 0.08. N, 4. N, 4. And T, 5 years. We calculate that on the calculator. I'll let you do that. 4,457.84. Now, what would the value of the CD be after 5 years if it was compounded monthly instead? So if we had a compounded monthly, the only thing we're going to change is the N. Now it's 12. Compounded monthly implies 12 times a year that it's compounded. So now in our formula, the only thing we're changing is putting a 12 in for N, calculate it out, and it'd be $4,469.54. So a difference of about $12 if it was compounded monthly as opposed to quarterly.